Welcome back. We are in pre-algebra, lesson 11, and we are going to talk about word problems about equal groups. Some word problems are about equal groups and can be solved by either multiplying or dividing. The key to working these problems is to recognize that the problems are about equal groups. To illustrate this pattern, I'm going to show you 3 stacks of pancakes. I have this one and this one. Let's see. Let's do 4 pancakes here. And I'm going to do 4 pancakes here. 4 pancakes here. I know these are not the best looking pancakes in the world. So if I were to add all of those together, I would end up with a huge stack of 4, 5, 6, 7, 8, 9, 10, 11, 12 pancakes, right? We could say 4 plus 4 plus 4 is equal to 12, or 4 times 3 is equal to 12. It's all the same illustration. This is basically a multiplication division pattern. The first factor is the number in each equal group, which is 4, 1, 2, 3, 4. And the second factor is the number of groups. We have 1, 2, 3 groups. So 4, 3 times, or times 3, is 12. So the number in each group times the number of groups equals the total. We know the factors. If we know the factors, we multiply to find the total. If we know the total and one of the factors, we can do the opposite or the inverse operation to find the missing information. So if I were to say 4 times some number equals 12, I could simply divide this by what I know. I know this is being multiplied times some number to get this here. I could turn this into the dividend and make this my divisor to find the unknown. Now, the way we do that in algebra is we use an x to represent some number we don't know. 4 times some number we don't know is equal to 12. I'm going to get rid of the factor I don't know by dividing both sides. And the reason I do it to both sides is because this is an equation. Whatever you do to one side, you have to do to the other. But the reason I'm doing it is to get rid of the factor of 4 in this sentence, in this equal statement. 4 divided by 4 is 1. 1 times x is equal to 12 divided by 4 is 3. So the x is equal to 3. And we say 1x, but you really only have to write the x because x by itself is understood to be multiplied times 1. But that is what you're doing to find the unknown value. You are doing the opposite operation. So instead of multiplying 4 times 3 to get 12, we're going to divide 12 by the factor we know to find the other factor. So let's try a word problem. I'm going to pause and type it up here for you. Or I'm going to write it. I'm not going to type it. All right, in our first example problem, 11.1, it says 42 students can ride on each bus. If there are 12 buses, how many students can ride to the game? So we are going to say 42 students per bus, right? 42 students per bus, and there are 12 buses. So how many students can go to the game? So all we're going to do is multiply 42 times 12. So we set that up like we're used to doing, regular multiplication problem. 2 times 2 is 4. 2 times 4 is 8. Now we're moving to the tens place. We're going to put our 0 in to remind us to move over. 1 times 2 is 2. 1 times 4 is 4. We add these together. That's 4. The 0 carry 1. That becomes a 5. So 42 times 12 is 500. 4 students can ride to the game. Easy peasy. You guys should be able to do these without a problem. All right. Let's see what our next problem is. All right, so I'm going to pause it and write it up here so I don't waste your time when you watch me write it. All right, so let me change this. This is 11.2, and it says 42 students can ride on each bus. There are 1,264 students who want to go to the game. How many buses do we need? So this is a division problem. We need to take the total number of students, which is 1,264, and divide them by 42. We're going to load each bus with 42 students until we understand how many buses we need, right? We're going to put 42 on the first bus, 42 on the second bus, but we need to know how many buses to call up in order to do that. So we're going to divide. So let's say 42 into 12. We can't do that. So 42 into 126. I'm pretty sure that that will go 3 times. So 3 times 2 is 6, and 3 times 4 is 12. All right. So that's 0. I'm going to bring down our 4. 42 goes into 4 no times. So 0 times 42 is 0, right? So bring down our 4. So we have a remainder of 4. So we have 30 full buses, but we have 4 students left. All right, we have 30 with a remainder of 4. So what we need to do is we need to add another bus to bring those last 4 students to the game. So you'll have 30 full buses and 1 partially filled bus, right? So 30 buses will have 42 students. 30 buses will have 42 students. And 1 bus will have 4 students. And that gives us a total of 31 buses. And that's something you can do. When you are doing your problems, don't be shy about labeling the numbers. When you label the numbers and you put your little labels here and there, the language helps us understand what we are doing. Draw an illustration if you need to. Whatever you need to do to illustrate it to yourself or to make a note to yourself that tells you what it means. Sometimes we put the numbers on the page and we understand what they are when we're doing it, but then we go back and look at it later and we go like, what was that 30 for? What was that one? What is that for? So write what it is over the top of it. Write what it is beside it. 31 buses. And 31 buses would be the correct answer. Because if we only did the 30 full buses, these 4 students would not get to go. And we don't want to leave anybody out. We want everybody to go and have a good time. All right, so I'm going to pause it and let's put another problem up here. All right, in this problem, 11.3, 560 students will be as evenly divided as possible between 34 buses. How many will ride on each bus? So we take those 560 students and we're going to split them evenly between the 34 buses. So let's see what we have. 34 goes into 56 one time. So subtract 34 from 56. We get 2 and 2. We bring down our 0. And then we can say, I want to say 6 will go into that. So let's try 6. 6 times 4 is 24. Carry the 2. 6 times 3 is 18, 19, 20. So that's 20. So we could subtract and we have 16 remaining, okay? So we can get 34 onto 16 buses. I'm sorry, 16 students onto 34 buses. But we have 16 students remaining, right? So 34 buses with, or I'll say at 16 students each. But now we have 16 students left. So what we're going to do is evenly distribute those students to the buses. So 16 of the buses are going to get one more student. So 16 buses, let's say 34 minus 16, 14, that'd be a 2, and that'd be a 1. 14 minus 6, that's going to be 8. Yes, 8. 2 minus 1 is 1. All right, so that's what we're going to do. 18 of the buses are going to have 16 students, but 16 of the buses are going to have one more student than that, so 17 students. So you see what I did? I took the 16 students we had remaining and subtracted that many from the total number of buses. All right, so instead of 34 buses with 16 students, we had to add a student to 16 of the buses, so that we have 18 buses with 16 students and 16 buses with 17 students. Now, the thing that you can do to check your math is to multiply. So we're going to say 16 times 18. So that's this, 18 and 16. 8 times 6 is going to be 48. 8, carry the 4. 8 times 1 is 8, plus 4 is 12. 1 times 6, I'm putting my 0 here. That's 6, and that's 1. When I add that together, I get 288. So I have 288 students here. And now for 16 times 17, I'm going to say 16 times 17. 7 times 6 is 42. Carry the 4. 7, 8, 9, 10, 11. Put in my 0. 1 times 16 is 16. Add it together. So I get 16 at 17 students, and that's going to be 272. And if you look at those numbers, those are pretty close, right? So 18 buses, and that's buses here. 18 buses at 16 students is 288 students. 16 of the buses at 17 students is 272 students. All right, that is all we have for lesson 11. So as you can see, you're going to figure out how you can evenly distribute things, how you can use the division or the multiplication to figure out where your solution comes from and how you can get there. If you have any questions, please let me know. We're starting to get into the algebra of the pre-algebra. In just a few more lessons, we're going to start hitting some harder things. So make sure you are mastering each lesson and you fully understand what's going on before you go to the next lesson. That is becoming crucial, okay? Because each lesson builds on the previous lesson, and if you miss something, it's going to take you longer to catch up than if you spend a few more little sessions working on the lesson. You know, that extra 5 or 10 minutes now could mean the difference in an extra 3 or 4 weeks later. All right, so give it the time it deserves until you understand what's going on. Even if you have to walk away and come back, that's fine. Make sure you get what is going on and understand how to solve. And I will see you in lesson 12.